sorry, got it. Okay. Yeah, I think we are live. Yes. So yeah, welcome everyone. Welcome to join another section of the Cronos Hackathon workshop. So today we're very happy to have Kathleen from Band Protocol, which is one of the very important member of the Cosmos universe that provide very fundamental building blocks for pretty much any DeFi protocol, and that would be the Oracle part. Yes, so she will be presenting the evolution and growth of decentralized oracles to us. Let's welcome.
All right, thank you for having me, Leslie. So pretty excited to be here today. I definitely remember the hackathon days that I used to go. But yeah, so I actually had a little bit of fun with this slide because usually when people think about oracles, they really think about it being a tool and infrastructure, and it's not a lot of fun. So my goal today is to try to tell a compelling story, almost like you would actually hear from a history class per se, about how we as an industry came to slowly realize the importance of oracles and other infrastructure, right, to help build a good, healthy ecosystem of dApps. Okay, so I guess we can get started. So decentralized oracles, I'll start with something that is a little bit attention grabbing, and nothing is more attention grabbing than just headlines of things. For example, in this case, compound user, I don't know if you can see here, compound user created for 49 millions, place Oracle blamed. And you think that would be, the only one, right? Like compound and the mistake that they made. But then there's also another thing happening with synthetics and more with another DeFi protocol and more. And if you look at the timestamp, this has happened since 2019 all the way to 2020. And even in this year, in 2021, there are still dApps that are suffering from this kind of headline. So you get the idea that there are dramas that happen because of the Oracle choices or the way that people get the data. Now, I understand that our audience today is mostly here as developers, and they're looking for ways to build different decentralized apps on ecosystem. And on top of figuring out, right, like the right layer 1 or layer 2 that they're building on, and other solutions, one thing that they want to know for sure when they make these development decisions is the goal is to make and create a safe protocol that does not only automate money, but actually secure the fund. This is because nobody would want to use a protocol that's not safe. So the goal here is to create a safe protocol that creates more usage. Now, more usage means more value to the protocol in the industry. And that's ultimately the bottom line that everybody is trying to go for. You're trying to build a product that in turns people find valuable. Therefore, people give more trust in the code that you put in the protocols that you have. And then you have more values flowing through you, and then you get compensated through in proportion to the level of contribution that you have. So here, it's really difficult to say that, it's like a no-brainer to say that. So good infrastructure and tools actually make it easier to build safer products. And from my experience working in the past with the Ethereum Foundation to grow the ecosystem through funding different protocols and different tools that the people inside of companies are building, and then later on in working with Band Protocol, which is a decentralized Oracle, I've actually been having really good opportunities to see the importance of building good infrastructure for the ecosystem so that developers who just want to develop dApps can just do that without thinking too much about it. So Oracle itself that we're going to talk today, in my opinion, is pretty interesting and very important. And today, the way we're going to go through and tell this story, we're going to look at Oracle as where it comes from, right? Oracle is actually a term that's originally used in computer science, and the incidents and how that happens, and how we as an industry slowly move away from using centralized Oracle to decentralized Oracle, and later on to later stages of now we're at Oracle aggregator, or the future of oracles, where innovations are happening in this space. So let's start with a fun fact. So I wonder if anybody here can just, think along with me and guess what an oracle, like the term oracle that we use in the blockchain world, where does that come from?
From Matrix.
From what?
From Matrix, the movie. No.
that could actually be it, right? But the Matrix got inspiration from this too. So an oracle in the Matrix is, like the woman you go to, and then you try to figure out if you're the chosen one. But yeah, that's a cool kind of oracle. But oracle actually in computer science has been a term that we use for a long time. And the oracle originally is actually a term used in computer science to just describe a black box machine, alongside the Turing machine that you have, that once you have a problem. An oracle is pretty much like literally defined as a black box that if you throw in some input, it solves a specific set of problems and give you back the answers or the output. As simple as that, right? And so it's been there in the theory of computer science, and that's why it kind of derived into where we are now. Now, the oracle in blockchain, as we know, right? It's pretty much still serve as that unit of computation where you receive an input and throw out the output, except that in the blockchain, the subset of the problems that it solves that we all know actually comes from the input itself is the data request, and the output itself is the data that was requested, right? So, but why is it that this oracle in blockchain is in the world that we know, the blockchain world, is defined to solve this specific set of data problem? This is because there's an issue with the way that smart contracts work. The smart contracts itself do not have the capability to actually make API calls directly. So normally when you want to get data from the outside world, you can easily make API calls, right? Whether through post, through get, whatever method you want to use, WebSocket. But that actually is not a capability that is in the smart contract, and that everybody knows. So that's why the oracle that we know here exists in the way that it does today, because the smart contract itself cannot communicate with the outside world, so it doesn't know anything else that's going on outside the sphere, the space that it lives in. So the solution for this one now that we write a lot of smart contracts that try to automate many of the funds, right? Like there's a lot of lending, there's a lot of borrowing, and in process to do that, you want to figure out, for example, if I want to lend this user some money, how much should I take in for collateral? And in order for you to figure that out, you need to figure out the current price of the collateral that you're going to be taking in, so that you can issue out a loan that is over collateralized. And that is a very, very basic use case that we see a lot in decentralized finance right now. So in order for us so far as an industry in the beginning to solve this issue of the smart contract not being able to connect with the outside world, the API, what we do is we start with, having an oracle, right? Like let's have an oracle, and that's, let's start it with centralized oracle. Now, centralized oracle in this case means it's just a solution that, for example, right, you're building a dApp and you just want this data piece. So you create another script or program that would go and get that data and then feed that data into the smart contract. So a lot of time when you do centralized Oracle, it's controlled by one party, aka you, or if you were to use another infrastructure service, it will be controlled by that party service. A lot of time, as I said, it is in-house. You just write something up and then you just get a bot to feed it. And unfortunately, in early days, as we all know, right? Because in the same way that we used to develop apps in other ways, you just need to get the data from one source. And that's exactly what we did. If our smart contract want the price of Ethereum, it just go ask the Oracle, hey, what's the price of Ethereum? Then the Oracle, which is a script, goes and talks to the API, retrieve back the price, and get back. And that's usually from one source. Now, this works well and fine. Like, if your smart contract works, it has the price you can use to figure out the decision that it needs to make. However, the happy ending doesn't really last that long. It's actually quite sad. It doesn't last long, right? Because I already spoiled you. And the spoiler that came from the beginning actually comes in I'm just going to talk about one aspect of it today. And that is itself flash loan, right? Flash loan is something that was very flashy, especially last year, because I think that was the year that we learned a lot about the importance of, that was the year that decentralized finance started taking off, Compound, Aave, right? And now we're at the point in the industry where we're building decentralized apps on top of these protocols, right? So it's like a scaffolding that keep building on each other. But flash loan was something that was there and around. I think it's going to keep working without some healthy measurement against it. So flash loan, let's talk about it in a really simple way. Flash loan itself, to put simply, is when flash loan pretty much is when you are able to take out a loan from a service, right? So you take out the flash loan and then you're from the one transaction. And then once you are, is a loan that you take out and then you return the fund that you borrow out in the same transaction. So what this allowed you is that you can just take out the loan, do whatever it is, and as long as you pay it back, everything is fine, right? It all happens in the same week. Yeah. And if, and you can program it in such a way that if some of the conditions are not met, it's almost as if you never take out the loan. So it's almost as if you didn't borrow, the transaction didn't happen. So what it actually allows you to be is that if you do it right, it allows you to take out a really big loan and allow you to be very well funded, very well endowed whale for like a slice moment of time. You have that fund, you can do whatever with it, go out with it, and then just repay with interest, right?
I love this example.
Yeah, that's what it is. Like, you can this is your chance to be a whale, but you only have one block of you just have one transaction. But the great thing is that, you can program it in such a way that, hey, I take out this loan, I'm going to try to do something with this, but if this condition is not met, revert everything, and it will be as if that you didn't take out the loan. Sure. So there's actually no risk for you, right? So this is pretty unique and pretty interesting, but also leaves out a lot of room for people to be really smart and take advantage of it. So in the way that it plays out, one thing that happens is DEX price manipulation. And I'll try to tie this back to how, at the end of the day, it caused a lot of damage to the protocols, and therefore Oracle is a solution. So let's say that, let's say that you are a bad guy.
Yes, I am.
You don't look like one, but you could be one. You could be one. Let's say, right? So what you would want to do is that first, right, you find a service and you take out a flash loan, right, for the amount of $8. So now you have a lot of money, and now you're like a really fat whale for a month.
Yeah,
right? And what you're going to want to do with that, if you are so smart and bad, is that you find a DEX, a decentralized exchange. And to preempt, usually the way a decentralized exchange works is that you have a contract that holds a reserve of money, usually two currency. Let's say in this case, it holds currency, A and B. right? And the way it calculates the price that these people come to swap and exchange between the two coins and the two assets is through a curve. So, but one thing about the curve is that the way the price has figured out is through figuring out the supply. The supply of the token asset A and token asset B is going to affect the price. So if suddenly there is a lot of token asset A in the pool, it would drive the price of the token asset A down, right?
Sure. Yeah.
So in this case, you have an exorbitant amount of money in asset A. So what you do is that you go to a DEX pool and then you dump a lot of money in that DEX, right? So you swap the token A asset A with token B. So now you're back with a lot of asset B of the same value. But what happened now is that the price in the DEX has been manipulated because you just dump like a really large amount of token A in there. The price of token asset A will go down drastically because, and then you take out token amount of asset B because the volume of asset B in the DEX is now much, much smaller. So now that you have token asset B, and you know that there's this one smart contract that lends out money and figuring out how much it lends out by looking at the price feed tied to that DEX that you just manipulated. All right.
Right.
So now you have a lot of token B assets, right? So you go to the smart contract and say, hey, I want to take this as collateral and take out asset A, right? But now the smart contract itself, right, because it's automated, now goes back, okay, all right, also you have token asset B, let me go look at the price.
Yep.
So it went and walked to that same DEX that you just manipulated, and it looked at the price. And it turns out that like, oh, wow, now the price of like token asset B is actually a lot, right? So I'm just going to issue you 150%. So I'm just going to issue you like the amount of token asset A that you asked for, but it's valued at a higher price, right? Because now token asset B you have worth a lot more than just a second ago that you just included. So now you come back with asset A again, right? With even more value than what you dump in the DEX.
You're right. Yeah.
Right? So now with token asset A, guess what? Remember the first line? You did take out a loan, right? But now this sum of like token asset A is much larger than what you took out. So what you do as a good, that smart person, you pay back, you take that bigger chunk of money, pay part of it back to the loan, and keep the rest back as profit.
And also, I think triggering that, the cost of triggering the entire sort of like flash loan attack is not high, right? All I need is just like in order to pay the interest of the flash loan itself.
Yes, and the gas fee to create all these transactions, to take
Yeah,
out
right.
the loan, to swap in the DEX, right? To take out another loan from the smart contract. That's it. So you came with nothing in your pocket, act like a whale, and kept millions of dollars. Right?
That's not the plan. I would just do it right now.
Yeah. Well, there were times where people were really going and after these patterns, right? But as you can see, if you just look at this diagram, the only reason why you could manipulate a smart contract was because you know exactly how the smart contract evaluates how much loans to give you. And in this case, you saw that like, oh, it's only gets the price from this one decentralized exchange. So you just went and manipulate that exchange and get what you want, right? And so this is actually, yes, the guy was bad, but this is actually by design of how the smart contract decide, right? Like how much to give the loans. If the smart contract were to say be smarter or to be a person, what you would do is that the smart contract would actually go ask many different DEXs to figure out like, hey, is this the current price? Is the price the same? Did you get around the same price as well? In order for them to decide if one DEX is manipulated or not. And this comes down to the redundancy of data sources. So this is a pattern, but this is also exactly what happened to Compound. So compound in this little tweet, literally the same thing happened. Somebody take out some flash loans, and then they did a swap to price manipulation because at the time compound was relying on the price from Coinbase Pro, and it was a centralized Oracle infrastructure that they had. And somebody figured that out, and they took advantage of it, and they kept the remaining 171 millions in DAI. Crazy, right? So I think ever since then, the industry itself really woke up to it, right? Because if a giant like compound that has that much usage can get exploited for 171 millions in just a matter of seconds, then any other growing protocols are pretty much subjected to the same risk. And even any other big protocols that are just as big at the time would also have more to lose. So the lesson learned here that I think everybody kind of learned at the same time then, after that incident point of history, is that people start to realize that how you get your data matters, right? So first, you can't just really query it from one data sources. One in this case, in the last case, usually like from one DEX or from one source like Coinbase Pro. Another one is so that like the way you get the data, sure, you can trust yourself, but as a user, right, can you really, what if Compound is the protocol that reports the data? Can we trust that messenger, that reporter, that they're going to be truthful in reporting the right data, right? So these are really the two things that starting to become in the forefront of people's minds more. So we are slowly, right, moving on to the idea of having decentralized Oracle. So the idea itself is not new. There were solutions that came before the incidents that happened. But, unfortunately, a lot, people don't buy insurance until things happen. The same kind of thing. So the decentralized Oracle in this case come and help solve these problems. And in most decentralized Oracle infrastructure, they usually just, solve the two things that I just said. So the first thing is to provide redundant data sources. And the second thing is to make sure that the unit in the middle where you go and compute and get the data sources is decentralized, and the messenger or the reporter has skin in the game, so that the people who report it is disincentivized to report the wrong data. In case, so like the sources can be right, but if your messenger is malicious and report the wrong data, by the time it arrives in it, it's still not good. So you want a system that really disincentivizes bad actors. So these are the things that kind of become the core of a lot of value proposition in the decentralized Oracle that we still even see today in the market. Now, the industry itself is evolving to do this even in a better way, right? So yes, save them with various sources, decentralized network, but also like the usual optimization, like can we do this but cheaper, faster, and more transparent so that people know what we're doing. And the case study today about how we're already solving this, I'm going to talk about band protocol, right? So band protocol, for example, offer like a really end-to-end customization. And I'm going just to try to walk through the architecture that the protocol has and see how we actually are solving this issue to make sure that the dApps that you might be building in the future is safe. Starting with the Oracle, band protocol Oracle itself, we start with a unit called an Oracle script. And this is where this is a script that you can actually write so that you can figure out what price you want. So you specify your query, and then you specify how you want, assuming because you are going to get this price from different sources, how do you want to aggregate them? For example, you want to medianize them, you want to find the average of them, and so on and so forth. Or you can even, because it's custom, right? You write yourself. You can even do any kind of things that you would want, find a deviation and reject it. And the third thing is you get to specify the number of what band calls validators, but in this case, they're actually essentially reporters. Like how many people do you want to go fetch these data from these end sources that you just specified? And on the other side, right, you have the data source script itself. And this is just, details of which sources you're going to go get from. So we have data source A, data source B, data source C, all of which would, hopefully report the same price, right? But they could report different prices. And then you have an actors, the validators, who are essentially the reporters. So in practice, what happens is that now when you want to ask for, say, the price of Ethereum, what would happen first is that we'll look at the first reporter. The first reporter will go to each of the data sources to get 3 prices, right? Which will then come back and report, here's the price 1 from source 1, price from source 2, price from source 3. And then the second validator, right, did the exact same task. And so as you can already see, there's not only redundancy on the data source side, but there's redundancy on the number of reporters. And then this reporter also came back and say, hey, source 1 says this, source 2 says this, source 3 says this. And then you go on, and then you can get to specify how many reporters that you want. But this is also to make sure that, you know, you can also catch like a bad flyer that, hey, in case if some reporters are not reporting the same thing, but they all go get these sources of price, the result for price at the same time. Now, once you get all these data, right, as I said, there is an aggregation method. So you come down, you compute in the way that you want to arrive at the price, the final that you would use. And this is how how Van Berkel tackled the Oracle problem.
I have a quick question here. So the data source is picked by individual validators. So they subscribe to like different data source, or they would have to subscribe to the same one?
So actually, it's very different. So in case of Van Berkel, it's end-to-end customization. So you can even actually go and set up the script yourself, right? And the reporters themselves would have to go to all the data sources specified in the Oracle script.
Oh, I see it.
Yeah, so it's pretty much works as like a menu that says, I want the price of Ethereum from source A, source B, source C, and I want 5 people to go fetch it. And so the 5 people will be randomly picked. So like, you know, you don't know which 5 is going to pick, and they don't know ahead of time if they're going to be picked for this task, right? So so anybody with a plan can be know for certain that they're going to be picked for this task. And then each of them will go and get these prices. Yeah, exactly.
That makes sense. Yeah.
So everything is really transparent. In this case, like you'll be able to see exactly like the source, and everybody gets the same price. There's you know where the sources come from. And you also are the one who specified where the sources come from a developer's perspective. So this is why it's end-to-end customization. But yes, but that's how, you know, and this is how you actually would do in like a normal app development, right? Usually you get to pick where my data source come from, how would you clean up your data, and how you'd end up actually using it. But now with a system in the middle where we want to have redundancy in sources and redundancy in the reporters, you get to specify that as well. So, but that is just one solution, right? And Oracle itself is very much evolving. So we so far have gone from understanding flash loan, the DEX manipulation problems, and how centralized Oracle does work. And of course, we see more movement towards using decentralized oracles. And decentralized in this case is because you've got a group of reporters, right? In this case, for band, they have to actually have skin in the game. They have to stake some token. And if they were to behave in the way that is not in that they should do as a validator, they would be punished for it. But pretty much like the whole entire system happens so that you can specify very precisely that this is how I want people to come to consensus about the price that we reported to my dad. And this is the consensus method that you use. And then, you know, from there on, right, because there are several Oracle solutions out there, we're starting to see a little bit more in the Oracle aggregator side. So there are people who are starting to use multiple Oracle to just create another abstraction layer to make sure that, okay, now that I got price from maybe Chainlink and from Band and from Hive and all these things, and I want to see, and I want all of that and arrive at the final price again. So the person who's using this, there's Alpha Finance Lab, Alpha Humor that's using Oracle aggregator. But this is on the usage side, right? Another development now that we are going to evolve they're actually more exciting things. Of course, anything, right? We want to build it cheaper, faster, easier for integration, so more scalability. But another thing that we're starting to see too is also more interoperability. And of course, a lot of these things here are the visions that I think what happened, the evolution, the next stage of evolution here is pretty much like aligned with what's happening at BAN, because we're implementing our, strategy, our strategic vision, right? But with the narrative of L1s and L2s and interconnectedness and cross-chain pools, it's really, really easy to see that the ability to be able to deliver data cross-chain is going to be very important. The more elegant, the easier user experience you can do it, the better, right? So for example, BAN Protocol has been starting to use IBC to send for people to really request a price natively through IBC and get the results back. So you just do that on your own, which is a much better development experience. Another thing too is right? And this is a big thing, is on-chain data economy. So if you think about the possibility of what dApps can do, you have to think about the ingredients that it has to work with, the tools that it has to work with. And data is one source of that, right? Without limited data, you wouldn't be able to do certain things. For example, if you don't have access to stock data, you wouldn't be able to make synthetic stocks, right? And so having a rich data ecosystem is going to be very, very important in fueling the growth and innovations that comes up in dApps. This is why one thing that I think will happen is that a lot of data providers that currently are mostly traditional institutions that work to get data and sell them to financial firms and financial services on Wall Street, I think it's going to be important that these data providers also come on the chain and started getting revenue and getting to sell their data on chain, right? This is because if we can onboard more data providers onto the chain, of course, you'll get richer data types and in turn better dApps. And the way that BAN protocol specifically is targeting this is that we just enabled our on-chain revenue model. So if you're a data provider, if you have something to sell in terms of data, you can pretty much go onto the platform, set up your infrastructure, very much like you set up your shop on Shopify or Shopee. And once your data is there, people are free to choose to request from your source. And as they send a request, you get paid directly without having any middleman. And that's the infrastructure that you get. So you have a shop you set up your API data that will feed the data. And then as people request, you just collect the revenue. And that is going to really lower the barrier of entry for a lot of people who want to provide data, creating more data. And therefore, we're just going to have a really solid rich data economy and rich data ecosystem. And I think that's where we're trying to go in, trying to bridge this gap of the data industry onto the chain. So yeah, so as we can already see here, right, like the oracles evolve in parallel with dApps, if not ahead, right? I personally think that, yes, like we pretty much work hand in hand. Whatever the developers need, Oracle solutions should be able to serve that and even better, predict that, right? We should have the data that's ready to use before you even think about using it. For example, recently there's a protocol that came to us and said, we want to build a derivative exchange and provide derivative products, but targeting Asian markets, right? The problem is, how easy is it to get Asian stocks to be on chain? And like the business side aside, being able to integrate and get that data to serve and integrate really quickly is going to be very important, for example, for that protocol to be able to differentiate itself and introduce new products to the market, right? Because that's actually new and that's a very legitimate targeted angle and value proposition that they can bring to the users. So this is what I'm waiting to see about what's happening next in the Oracle sphere and how it just keeps growing and fueling the overall dApps economy. So let's see what's next. And if you want to hear my thoughts more on the infrastructure side of things and other things, you can follow me on Twitter. Thank you.
Yeah, right. Yeah. Thank you very much for very in-depth, um, uh, well, you give an overview of like why would we need this decentralized Oracle, and also you go into very details on like how band protocol handle that, especially on the Oracle script side. And I think that just a quick question on the Oracle script. So it also comes with like a price, right? So okay, I'm trying to request data from validator 1, 2, 3, and then it also comes with price. Is there like a price market on that front?
So there's a request that you made, right? So
Yeah,
like the
yeah.
way, because for example, Bannerco itself, it is a chain, right?
Mhm.
And when you send a transaction, say hey, this transaction is actually a data request, and you specify, or you say that I'm going to make a request through Oracle script A, and
Mhm.
in Oracle script A has a menu of 3 validators,
Yep.
5 data sources querying Ethereum price, right? So you would just pay the transaction fee plus the data
Oh,
sources fee,
I see.
right?
I see. Mhm.
So the way the validators, do they get compensated? Of course, right? So the way that you participate as a validator is that in order for you to be a validator, you hold a certain token amount of band token, right? And
Mhm.
stake it
Yep.
so that you're really incentivized. If um, somehow you didn't report or your downtime was a lot, you get slashed, right? But
Yep.
other than that, as a requester, you pay the transaction request, you pay the data fees, and of course, some of it I think goes to the validators too. But yeah,
I see. Yeah.
yeah.
I think we are very. I believe that there's already been happening the update for band protocol several weeks ago, I believe, which also enabled the IBC as you mentioned. I think because Chronos in the future will also be um, it is a Cosmos SDK based chain, and also we would have IBC support as well. So I would just like to know, like, how does it work? Is that would I be able to call like certain kind of like Ethereum price from other chains, say like Cronos or Crypto.org chain? I can send a an IBC transaction to BAN and trying to get this data from BAN protocol. I believe is that how it will work?
Yeah, it's actually that easy. So we actually make it even easier too. We work with the Tindermin Cosmos team themselves,
Mhm.
right? And we have a module called the Band Oracle module,
Oh, I
right?
see. Mhm.
Which comes with Starport. So you can actually just, go ahead and install that module. And once you have that module template set up, you can pretty much just do exactly what you said. You send a request data package, right?
Mhm.
And then you get the results back. And as you know, with IBC, it comes with the guarantee that the result you get actually truly comes from benching.
I see. But
Yeah.
I might have a like rather technical question on this. It's like as some of us, well, I mean, the audience here will be developers, so they have experience of working with IBC. And one of the tricky part right now that we have with IBC is like the fee, because the relayer pay for the fees, and in that case, if I'm trying to call bank protocol, I want to get some like Ethereum price, and how should this work? I should like say I'm starting from Crypto chain. I have this CRO token, and I would like to pay the other side, band protocol validators with band token. How would that foresee that this is going to work, or how do we resolve this?
So I
Yeah.
think you're trying to figure out the cost estimation of how much money you would
Mhm.
have to it, right? So actually, that's a really good question. And I think there's a detailed explanation on the documents that
Mhm.
we have. But yes, right now there's actually like, it would be great if we have an interface, right? To know and to estimate out like, okay, so how much is this going to cost? But I think over time, like it does stay roughly at the same. So if you one transaction kind of send out, you kind of figure it out.
I see. Mhm. So I think this band Oracle module has already been in Starport, as you mentioned. That is it. So if some of our audience here would like to try that out, is that ready on band testnet or on
Yeah.
mainnet?
Oh, it's also already on mainnet and
Oh, I
testnet.
see.
It's
Okay.
also on Star Wars. So, you know, go wild, have fun.
Yeah. So yeah, I think that's yeah, yeah. I was trying to like read comments and yeah, pretty cool. And they say like, thank you, Kathleen. Yeah. Okay. Yeah, it's nice information, and yeah, really appreciate to have you here today to share with us on the centralized protocol, the how does it goes and what is like the future direction of that. So yeah, thank you
All
very
right.
much.
Yeah, thank you for having me. Thank you so much, Leslie.
Yeah, no worries. So yeah, so this will be today. So everyone here, where the hackathon is happening. You know, well, Cassini, the incentivized testing is just finished, but the hackathon is still happening, and then it is going to finish on the 24th of November, and there's a 500K prize pool over there for you. So yeah, let's keep building. Thank you
Yes.
very much.
All right. Thank you so much. Good luck,
Yeah.
guys. Bye-bye.
Cheers.